Today we are doing 11.6, which is perimeters and areas of similar figures. So our I can statements today, I can understand the relationship between perimeters of similar figures. I can understand the relationship between areas of similar figures, and I can find the ratios of perimeters and areas of similar figures. So our key ideas here, perimeters of similar figures, the ratios of their perimeters are the same as the ratio of the corresponding side lengths. This is actually very much the same as what we did for in chapter 15, where we looked at similar solids and we looked at changes in volume and surface area. Same thing today, except instead of volume and surface area, we're looking at perimeter and we're looking at just regular area. So the ratios of the sides is going to match the same as the ratios of the perimeters. We don't have to square it or cube it or anything like we did in chapter 15. We just need to write the proportion and then solve it. So for this first one, it says find the ratio red to blue of the perimeters of the similar rectangles. So red to blue, that's the order we need to write it. So I'm going to put my red first, which is 4. And then I'm going to write my blue 6. I don't need to square it or cube it or anything. The perimeter ratio is the same as the side length ratio. But like all ratios that we've done so far this year, we do need to make sure that our final ratio is in simplest form. So when we simplify 4 over 6, and I did that by dividing 4 by 2 and 6 by 2, I get the ratios of those perimeters is 2 to 3. All right, so let's take a look at this one. It says the height of figure A is 9 feet. The height of a similar figure B is 15 feet. What is the ratio of the perimeter of A to the perimeter of B? Pause the video. Go ahead and try this problem. Okay, let's check to see if your answer is right. So here's the order we need. Perimeter A to perimeter B. So A was 9 feet. B is 15 feet, so I'm writing them in the right answer, or the right order there on my ratio. And now I'm going to simplify. So both 9 and 15 are divisible by 3. 9 divided by 3 is 3. 15 divided by 3 is 5. So my simplified ratio for the perimeters is 3 to 5. Okay, so now I'm going to do the same thing for the areas for the figures, except this time my area is squared. Just like surface area for the solids, those were squared in their relationship. That's because it is changing by both length and width. There are two different dimensions when we're multiplying with area. So area of the similar figure, same thing. We're writing the ratio and then we're squaring it. Okay, so for this one, write the ratio red to blue, so that's the order we need to do, of the areas of the similar triangles. So we're going to go ahead and write it 6 over 10. And then because it is a ratio, we need to, a ratio of areas, sorry. Because it's a ratio of areas, we need to square it. So 6 squared is going to go in my numerator, which is 36. And then 10 squared is going to go in my denominator, 100. And then I need to think about how can I simplify it. So both 36 and 100 are divisible by 4. 36 divided by 4 is 9, and 100 divided by 4 is 25. So my ratio is 9 to 25. Now, I can, if I want to, simplify my ratio first before I square it. If I wanted to do it that way, instead of 6 over 10, I could have written it as 3/5 squared. So I just simplified my ratio first and then squared my simplest form ratio. So 3 times 3, that's going to be 9. 5 times 5, that's 25. Same answer as above. So you can simplify at the end or you can simplify at the beginning. Doesn't really matter. But you do need to make sure when you're finding the ratio for areas that you square the ratio. Let's take a look at this next one. The base of triangle P is 8 meters. The base of a similar triangle Q is 7 meters. What is the ratio of the area of P to the area of Q? Pause the video and try this problem. All right, let's see if it is correct. So we're doing P first and then Q. That's what they ask us to do. So 8 is going to go on the top, and then 7 is going to go on the bottom. And then it is area, so I need to make sure that I am squaring it. So 8 squared, it's going to be 64. And then 7 squared is 49. And that's my ratio, 64 to 49. Let's take a look at this next one. A swimming pool is similar in shape to the volleyball court. Find the perimeter and the area of the pool. So we're going to use the picture to help us out here. So I have the pool, and the bottom part of that is 18 yards. And if I scroll this down here, I can see the tennis court is 10 yards. And then I have the information about the tennis court there. And I need to find the perimeter and area for the pool. Okay. So I'm going to start with my perimeter. Okay, so I'm going to put my tennis court information on the top. It doesn't really matter. I'm just choosing the smaller numbers to go on top. So 10 over 18, those are our corresponding sides. They're the shorter sides of the rectangle. And then perimeter is going to be the exact same ratio. So my tennis court one was 60. And so now for the pool, I don't know what that is. All right, so now that I have my proportion set up, I'm going to go ahead and solve it. I see a multiplication problem side to side, or a pattern. There, 10 times 6 is 60. So I can do 18 times 6 to get my x. So that looks like that's going to be 108. And then that's going to be yards. That's my answer for the perimeter. Now I'm going to do the same thing for the area. I'm going to start with that same ratio, the 10 to 18. But this time, because it is area, I need to make sure it's squared. And then it looks like the area for the tennis court is 200 yards squared. So I'm going to put 200 here. And then I'm going to put X on the bottom. So I'm putting the tennis court information on the top. I'm putting the pool information on the bottom. I'm going to give myself a little bit more room here. So before I do anything side to side with the proportion, I need to square my ratio. So 10 squared is 10 times 10, that's 100. Then I need to do 18 squared. So let's see, 18 squared is 324. So I have 100 over 324 equals 200 over x. Again, I'm noticing a multiplication problem. If I take 100 times 2, I get 200. So I'm going to do 324, and I'm going to multiply it by 2. And that's going to tell me my value for x. So that one's going to be 648. And then area is always in square units, so I want to make sure I have square units on my answer. 648 yards squared. All right, my last one here. The width of the pool is 16 yards. Find the perimeter and the area of the pool. Go ahead and pause the video and try these problems. Let's see if you're right. Okay, so the perimeter. Top is still going to be 10 on these problems, but now instead of 18 on the bottom, my width is 16. So I am doing 10 over 16. Okay, and I'm going to go back a second just to double check here. Okay, so yep, I've got 10 and 16. It looks like my original for my volleyball court was 60 for my perimeter. So I'm going to come back over. I'm going to put 60 over x. Okay, so actually, now that I'm looking at it, I think, oh no, we set it up, never mind. So I'm going to multiply by 6 and multiply by 6, so 16 times 6 is 96. So there I'm going to have 96 yards for my perimeter. Okay, now I'm going to do the same thing for area, but of course, remember we need to square when we're writing a ratio. So 10 over 16, that's going to be squared because this is an area problem. And then I had 200 for my area, and then I'm looking for x here for my area for the pool. So 10 squared, that's 100. If I do 16 squared, I get 256 equals 200 over x. When I multiply each side by 2, 100 times 2, that's going to give me 200, and it looks like my x here is going to be 512 yards squared.